I'm Brian Acosta, and I'll be doing question 7.
Question 7. In the cold vulcanization of rubber, disulfur dichloride is used as a source of sulfur atoms, and those sulfur atoms form bridges or crosslinks between polymer chains. Sulfur to S2Cl2 can be produced by reacting molten sulfur with chloride. What is the maximum mass of disulfur dichloride that can be produced by reacting 32 grams of sulfur and 71 grams of chloride? All right, so immediately looking at this, they give us 32 grams of sulfur right here and 71 grams of chloride. Immediately what I'm going to do is set up my equation for the reaction of sulfur and chloride, and that's going to be the product that they give us in the question. And I'm going to go ahead and balance the equation, because as you can see, this equation, there's too many sulfurs on this side compared to on this side. So I'm going to go ahead and balance it right here. So let's see, there's 4 times 2, there's 8 on this side for chloride. And now there's 8 on this side as well. And there's 8 sulfur on this side and 8 sulfur. So it looks like we're balanced. So just as an explanation of what we're going to be doing, we start off with the mass in grams of the reactants of what they gave us, which is right here. And we're going to use the molar mass of each reactant to convert to moles of reactants. And from there, we're going to use the balanced equation we just balanced right here to figure out which of the reactants is our limiting reactant. And then from there, we're going to use the molar ratio itself, which are these numbers, to see how many moles are produced from that limiting reactant of the product. How many moles of the product were produced from our limiting reactant. And then we're going to use the molar mass of our actual product to find the maximum mass of our product here. So getting into that, so the first step right here, first step number 1, I've already labeled it for you, but I'll go ahead and explain how this process works. So pretty much they gave us 32 grams of sulfur and 71 grams of chloride. Now you might be wondering how I got this number. This is the molar mass, exactly what I listed as here is what we're going to use to go from grams to moles. So 1 gram of sulfur is equal to 256.8 grams per mole. So if you take a look at your table of elements here and you look at sulfur, sulfur has a mass of 32.06 grams. So looking at our sulfur that they gave us, there's 8 of them. So 8 times 32.06 is 256.48. Plug that in, do some little bit of math here, and you'll get this number of moles, 0.1248 moles of this. So I'll explain this divide 1 in a little bit. But coming down to our second reactant, chloride, 71 grams of chloride. Once again, this is going to be the molar mass. We're going to take another look at our periodic table here and see chlorine has a mass of 35.45 right here. Going back to our paper. 35.45 times 2 is 70.09 grams. So you're just going to plug it in right here. Our grams are going to cancel out, and you're going to be left with moles of chloride. And it's once again 1.00141 moles of chloride. Okay. From there, we've reached this step, and we've got moles of reactant, but now we want to figure out which one of these is our limiting reactant. So from there, we're going to see, if you actually look at this equation right here, you can tell that if every reaction, we use up 1 mole of sulfur, 4 moles of chloride to produce 4 moles of this substance right here, disulfur dichloride, I'm thinking. Okay. So now coming back, we can calculate which one is our limiting reactant with our knowledge from this equation and say, oh, 1 mole is used for every reaction, but 4 moles are used for every reaction for the chloride. So divide by 1, divide by 4, and you're left with moles of this necessary for 1 reaction. So from here, we can clearly see that this is our limiting reactant because this number is smaller than this number right here. So sulfur, just as I've labeled, is our limiting reactant. So moving on, now that we identified that sulfur is our limiting reactant, we're going to go ahead and use our number for the number of moles of sulfur, and we're going to now convert that using our molar mass. Whatchamacallit, right here, molar mass to, let's see, we found our limiting reactant, and we're going to use the molar ratio to actually convert. Okay, so once our sulfur is the thing that's limiting the actual reaction, we're going to find out exactly how much of this is produced using this molar ratio. So if you come down here, let's see, 0.10148 moles was exactly the moles we found previously. Now using a molar ratio of 4 moles of our product to the amount of sulfur, we find that we get 0.44906 moles of disulfur dichloride, which is exactly what we're looking for. Now on to the final step. We're going to actually grab these masses of disulfur dichloride and use the actual weight, the molar mass, just as I showed previously on the actual reactants. But this time we're going to do it for this product, so we can convert from moles to grams. So actually, you're just going to look at your periodic table one more time here. You're going to see that this is 32.06 and this is 35.45. Using some simple math, I actually don't think I wrote down the multiplication, but I think you can figure it out. It's 2 times the amount for sulfur and 2 times the amount for chloride. And then from there, you add them together and you get this amount of grams. So multiplying these moles times these grams, and you get 67.34 grams of sulfur dichloride, which is your answer.